Welcome everyone. This is another AI learning club. I switched the name. It's not reading club anymore because we're not reading today. It was a video. So to be inclusive, it's AI learning club at this point. Welcome everyone. Today the session is going to be led by Maddie. So let her take over.
Cool, thanks so much. So did everyone watch the video? Show of hands. Nice. Okay. First impressions on the video.
It felt like a summary of the last two chapters we were reading, so that was a good thing. I think there was still a lot to discuss over the chapter, so it gives us more time to go over that.
And I think evaluation is such an important thing. We're constantly talking about it in our day-to-days, and I think it's good to not only learn about evaluation techniques that like apply generally. I think it's good to discuss what we can apply to GitLab specifically as well. So I'm excited to keep the conversation going. Like Eduardo always does, I just have like a little slide deck that I prepared for those that didn't watch the video. The video was about how do we evaluate LLMs, and it was a 10-minute video. And it discussed how to quantify and evaluate the performance of models, how to, or understanding the methodologies, and like a little discussion about why it's vital. And what this person in the video said that we should look for in a model was how it can complete assigned tasks, such as like question answering, summarization, generate code, and then whether it's robust and fair. I think there's a lot more things that you can look for in a model, things like latency, size, whether it's open source or not, what the data is trained on. But this is what the video focused on. And he basically had 3 methods used to evaluate LLMs. Same thing that we saw in the last 2 chapters. The one is about automated benchmarking, things like accuracy, precision, recall, using models as a judge, and then also like very important, using humans in the loop, and using humans to basically say like how well does this result measure in terms of quality and accuracy. And yeah, I'm just going to highlight 2 things that stood out for me that I learned from this video, which is calibration and G-eval. The calibration is basically using the confidence that a model's output gives, and comparing that to the accuracy. So you break down the scores that the model has in terms of confidence into different buckets. And then you also calculate the actual accuracy for each of those buckets. And then if they are super close, it means the model is well calibrated. If it's, say, for example, the model says, I'm 70% confident and 70% of the predictions are correct, then the model is well calibrated. That's something I learned. I don't know, did everyone else find this interesting?
Yep.
Cool. I don't know if it's something that people look at often, but for me it was cool to see. And then for G-eval, it's also a different methodology. Instead of just using a LLM as a judge to basically in the step to say like how well is this task performed, you then ask the model to explain the reasoning for every part. So for example, why did you include this? And then based on like predetermined criteria, it fills out a sheet of how well it did on specific tasks. And I thought that was also quite interesting, where you use the LLM to do more than just like, is this good or bad? You also use it to like explain the reasoning, and yeah, that was interesting to me. So for me, the takeaways was always combine the 3 methods: humans in the loop, automated tests, and models as judges. And then generalize, so look at existing measurements and leaderboards, existing data sets, but then also be specific. You should be specific about what you measure should correlate to what the task is that you want to perform at the end of the day. It doesn't matter that it's good at doing something and the precision is really high if you're measuring the wrong thing. So that was basically for me the TLDR. Yeah, that's the end of my slideshow. Let's go over to the agenda and get the conversation started.
Okay, I will take notes on the discussion. Yeah, for
Cool.
me, that part of measuring the right thing is so important.
Mm.
We discussed a lot of the non-deterministic, let's say, approaches.
Mm.
But I see very few discussion over, like, we were discussing functional correctness, but we don't
Mm.
have, for example, in GitLab functional correctness implemented as one evaluator. And we also, like, this video didn't even touch really on functional correctness, and this can have different formats. So we were talking with vulnerability, the features, and a type of functional correctness is pass the code that had a vulnerability through the scanner again and see if the vulnerability was there. It doesn't really need to be a test, a code test or something. And I think it's something, it's about measuring the right things. Like, what is the outcome that you actually want to achieve with this thing you're building, right?
Yeah. And I think yeah, that's a hard thing to kind of install because you need to understand the system. And I mean, requirements are super hard already for software projects. I think we can do a better job in general in software projects to set requirements and measure them before and after. But especially for AI and machine learning projects, I think sometimes it's just like, it sounds cool, we want to have AI, and then at the end of the day, it's like, did it actually make a difference? Did it actually achieve what we needed to do? So yeah. What does everyone else think, Dimitri?
I just want to mention something. During the LLM re-ranker experimentation, I've tried to re-rank the code results manually. And that was very tricky because I realized that a lot of engineers have kind of their biases. Maybe they want to see tests before QA results or something, or vice versa. So I'm not sure how to solve this problem, honestly. So it might be very different for code results specifically.
Mm-hmm.
Just want to mention this observation.
Yeah, functional correctness is not always possible. Yeah, you're ready. Okay, I'm gonna. It's not always possible. A lot of validation itself is context dependent. So validation that is good for one use case is not for others, and this is why it's so heavily dependent on feature that you're trying to build. Specifically, like the whole search has its own set of metrics that make it challenging in its own way. Yeah.
Yeah. Getting back to the bias as well, I think something that the person in the video mentioned was to overcome human bias, you have to have like super clear instructions and perform it at scale. I think that's the only way you can like get the average of, something like ranking results. If someone says tests should always be higher, and you take that as like the gospel, then that's what the system is going to do. But if you have it over like thousands of developers ranking it, then we'll get a better answer. But it's also, like you mentioned, it's super difficult. It takes a long time. It's expensive. So, like, how do we incorporate that? We know it's important, but how do we incorporate that into our GitLab projects? Yeah. Um,
I'll jump in with my next question
Mhm.
if there were no other things on the last topic. Yeah, I just wanted to ask if we do anything like G-eval or calibration, since those were the two things that you called out from the video, Maddie.
Andres, I think you know about this, right?
We don't do calibration, but we do LLM-based eval. But we're actually starting to see the limits of this. Like with the vulnerability resolve came up as an example. A lot of times we see the judge looking at the results and saying like, oh, this is very correct. But if you look at functional correctness, the vulnerability was not resolved actually. So we do that, but we're investigating new ways to improve it. One way could be, so we're looking at this hybrid solution, like, okay, let's check functional correctness. Let's see what the judge says, and let's take these two results together. And maybe if the functional correctness says it's good and the judge says it's good, we say, okay, it's good. But if the two contradict, we might want to throw away that result, that specific evaluation result, or improve the calibration somehow.
This might be a precursor for a human evaluation. So if they disagree, it goes to the human judge eventually.
Yes.
I think throwing away is wasteful, because this can be nice information for the judges later if you want to improve as an examples of even examples to ourselves. Like, okay, we want to improve, because validation is not also just for telling if it's good or bad. Validation main purpose is to identify where it can be improved. So if you identify on the validation that, I don't know, it's failing for some specific cases, that's like the errors are important. They're just not like a number, right?
Right. We also have a very interesting problem with LLM-based eval is that we're also kind of evaluating the super model itself. So there was the case of vulnerabilities. Some models, top-level foundation models, refuse to answer to evaluate responses because it contained vulnerability, and its ethical guardrails said that it cannot be part of hacking attempts. So that's also a dimension of this problem, that foundation models in general are super useful, but in some cases they might unexpectedly fail. And it's hard to predict when and how.
Yeah, one thing that was striking me as I watched this video is that our use case, especially with, let's say, dual chat, where we use Claude, is a little bit different than what they're talking about, because we're using Claude, which is already evaluated on its own terms, and we're using it. We're trying to evaluate how our prompts work. We're not really evaluating the model as much. So I wonder if there are any resources about that, or if anyone else kind of, was thinking about that, how we're not evaluating the model, we're evaluating our prompts for a given model, and like what differences that might have in our approach.
I think a lot of the discussions we're having, we might use model, but we're really evaluating the application, like the final thing that the user might see. The book in itself splits into two chapters. The first one is like by evaluating models, metrics that are more academic at the model level, and then another one at the prompt or application level. And these are more application level already. That's what I understood from the book as well. They were more from the video. They were a little bit more targeted for prompt and final application evaluation.
I have a follow-up question about human eval. Like, I know for evaluating models and training models, the book that a few chapters back talked about using like tons and tons of people to go through manually and rank results, or paying specialists, but then there's the cost associated with that, especially like the more complicated the subject matter. But what would this look like practically at GitLab if we were going to implement human eval? Would it be something like I run an eval on Langsmith and then I go through manually a small data set and then like rank whether it was right or not? Or would this be something that we end up outsourcing or going through a series of engineers at GitLab? Like, I don't see how we would make this actually functional at GitLab.
Yeah, it's a good question. I think one of the things you can do is get feedback from the features themselves. So you could be like, thumbs up, thumbs down, this was useful, this wasn't useful. And that's like in the video, they call that an online approach or something like that, where you get feedback based on the end goal that the user was trying to achieve, which at the end of the day, that's the most useful feedback because that they get what they expected. But then in terms of like your question about maybe I want to introduce a new model and I want to evaluate it, I can run it through automated tests and I can get back nice metrics like accuracy and recall and everything. Where do I put the human into that? And I don't know.
Yeah. I think there are a few scenarios. So one level of human evaluation is like you are coding and you are creating the data set, you're inspecting and you're inspecting and then you're changing and evaluating the results yourself, right? That is the first, let's say, level of human evaluation. Then there is outsourcing. Like you said, we want to do this at scale. So we're gonna either have our own, we have people, whether outside or inside, evaluating those questions. It can be like a daily exercise, or it can be implemented as a game that you evaluate, like you get points for completing things, similar to how folks do translations as well. So our translation systems work in a similar way. We have all of the strings that need to be translated. We have an external system where people can go and translate them. It would be much. There are some techniques on how to do this. For example, you don't want to be dependent on a single, like a person that reviews a prediction by biased for a reason. So you need to give that same problem to multiple people, so that you have like a collection of votes or ideas about that specific one, and you can cross-reference later. You can take measurements. Another thing is that people are better at ranking rather than they are at saying if something good or bad. So instead of saying, okay, is this answer good or bad? So you ask which one is better. And this, I think, could also be applied to LLMs. So instead of pushing LLM to, like LLM as a judge to answer if something is good or bad, ask the LLM either to improve that or to even say, okay, which one of these answers is better. That could also be some good approach. But either way, it costs time and money. And we don't have I don't think we do have, like, thumbs up and thumbs down is one way of doing human evaluation. It's just there's very little information on a thumbs up or thumbs down for this kind of scenario. But it could be an idea as well. And I think we already have thumbs up and thumbs down, right?
We have like in the IDE at least, we only have give feedback to improve this
Yeah.
response.
Even something like a code acceptance for code suggestions is a form of human evaluation, right? It's I would say it's the ultimate form of human evaluation because it's the actual users that are actually using it and doing their day-to-day. Like, it's the thing we want to evaluate. Everything that we do is a proxy to get to that point. We're trying to anticipate that actual final value, and improve the actual final value. But that is our human evaluation for code suggestion right now. If we can do that before, that would be better, but we don't have a setup.
I guess you can do like beta testing or A/B testing where you release a feature to a set of users and you measure things like code acceptance rate for the A and the B and see which group has the better response to a feature that you have or a change you made. That's also probably something you can do.
Yeah, I A/B testing is something I used to work in the past, and I miss it so much because it gives so much, like, both in terms of product, because it's not really only for LLMs, it's for everything. Like, does your code that you push is improving any kind of anything, or is it dead weight? Is it making it worse? Like the impact on database. What's the impact on, I don't know, time? I really wish we had a better setup for A/B testing. I think it will be necessary for this.
Andres, do you have any other thoughts?
Regarding the A/B testing.
Just in general, evaluation, the video, if you watched it, anything else?
Just regarding the video, one thing that stood out to me, it focuses a lot on generalized benchmarks, but in our use cases, we usually need something very specific. Like we have a product and they want to know that this performs this task very well. For code suggestions, we don't care if the model can also cite Shakespeare on the side. We want to know that the code suggested is top notch. So a lot of these benchmark a bit too generic, in my opinion.
Yeah.
That's also why why we create our own data sets for most issues instead of using publicly available ones, because if you want to rate a model as a research project, then yes, you need these benchmarks, but most use cases you want something specific.
I think the same way that, like, when you think about creating software, you think, okay, I'm gonna pick the requirements, I'm gonna write the code, I'm gonna write the tests, I'm gonna do the kind of thing. That's the same with AI engineering. Building the data set is part of this flow. It's just something that is there, just like writing tests is for software engineering. It's important, it's fundamental to get there. It's a cost that we have not associated yet. It feels weird. It feels a little bit, I don't know, wasteful time. But and it's difficult as well. Like, it's not an easy test. Like, but it forces you to think on your use case at the same time. It's like the same way that you do the same benefits of TDD. Is the same thing you have here, evaluation driven development. Like, you first write your evaluation flow, and then you start building the feature. Same problems, same ideas, I think, same benefits.
Agreed. Want to make it a first class citizen, that evaluation is really important. Yeah.
Yeah. I think we are learning, like, I see on the company, every few weeks, the main word changes. So, and now at least the last 2 weeks, and I think it's going to continue for a month, it's data sets. That's the biggest, the most repeated word across the company. And it's just that we are figuring out the challenges, and this is the challenge we need to figure out now.
Nice. And I think that's time. Thanks so much, everyone, for joining, and for those watching the video afterwards. What is next week or the week after next, Eduardo?
We have another chapter and I think the next one we should split in two, because it seems to have quite a lot of content. But if anybody wants to talk about something, you are free to suggest and to organize. So thank you very much, Maddie, for jumping in and signing up to run this one. This can be a video that you're finding interesting, a specific paper that you want to join, that you want to, I don't know, you always wanted to read, but you never had the time to do so, or a video that you want to go through. So, well, you're welcome to bring anything, really. Anything brings value to this conversation. We might even read at some point the paper on our evaluation. We have a paper on our evaluation mechanism. We might even discuss that one. I think that would be very interesting to bring along. So yeah, thank you very much. If you have any ideas on something, just reach out. I think for the next one, we will have the book, the halfway, at least a chapter of the book, and then we'll figure out the next one. So thanks so much.
Thanks, everyone.
Bye.